Hello friends, today's question. A person of mass m is sitting on a swing to length L and swinging with the angular amplitude theta naught. If the person stands up when the swing passes through its lowest point, the work done by him, assuming that his center of mass moves by a distance small l, where small l is very much less than capital L, is close to. So we are given that a person of mass capital M is sitting on a swing and the length of the swing is given as capital L. So in this case we assume, or rather we can say, this will be its center of gravity and it is moving with the velocity of v0. And in the second condition, the person stands up. This is a string and now the person stands. Let us suppose something like this, and it says that center of mass moves by a distance L. Let us suppose this is the distance L by which its center of mass moves up, and in this case we assume that its velocity is given as v1. So if total length is L, so therefore this distance will be given as L minus small l. As here we can use the conservation of angular momentum. We can say conservation of angular momentum now this is when the person is sitting and this position is when person is standing. Therefore, the conservation of angular momentum, we can write this as initial is m v0 and length is string is capital L, and in the second case mass remains same, velocity becomes v1, and now the string length becomes L minus small l. So from here m and m cancels out, so we can say that the v1 will be equal to v0 L divided by L minus small l. Let us call this equation number 1. Now it is given, or rather we can say that as it is swinging from one extreme to another extreme and it is given the angular amplitude is theta naught, therefore we can say that the work done, or rather we can say the change in kinetic energy will be equal to change in kinetic energy, which let us suppose is given delta Ke, will be equal to work done gravity plus work done by the person according to the conservation of energy. So change in kinetic energy, we can write that delta Ke will be equal to half m v1 square minus half m v0 square, and let us find out the work done for the against the gravity. So we can say work done, gravity. Now in this case we have mass m, so mg will be acting in a downward direction and the displacement is in upward direction, which is given as small l, because it moves by, the center of mass moves by distance small l. So they are both in opposite direction. You can say the work done to the gravity can be written as, now the angle between the two will be 180 degree. So we can write this as minus mgl. In this case we have force mg acting in downward direction and displacement of center of mass by L is in upward direction. So therefore we get the work done against the gravity will be equal to minus GL. Next is the work done by the person, and you can say let, suppose work done by the person is given as WP. So if we substitute these values in the equation, we get the equation as minus mgl plus WP is equal to half m v1 square minus half m v0 square. Now we can use equation 1 and substitute the value of v1 in this equation. Using equation 1, we get minus mgl plus WP will be equal to half m, and v1 is our v0 L divided by, sorry, this is capital L, L minus small l and its whole square, and we can take this half m as a common, and this will be equal to v0 square. So from here we can write that WP will be equal to mgl, and taking v0 also common, v0 square rather, so we are going to have plus half m v0 square, and this will be L minus small l whole square minus 1. We can modify our right side, so we get this as mgl plus half m v0 square. So we can write this as 1, and you get 1 minus L upon capital L whole square minus 1. We can make further modification for the ease of simplify by using the binomial theorem. This is half m v0 square, and we get this as 1 minus L capital L minus 2, and this is minus 1. Now it is given, or we can say expanding this term specifically, expanding using binomial theorem, and it is given that our small l is very much less than capital L. Under this condition, we can write that WP is equal to mgl plus half m v0 square, and this becomes 1 plus 2L capital N minus 1. 1 and 1 cancels out. So we are left with WP is equal to mgl plus half m v naught square and 2L upon capital L. Now we can further solve this thing, and by using the angular displacement which is given as theta naught. So we will be given that the angular displacement is theta naught and v naught is the velocity at the mean position. So let us suppose it is moving in this direction with the velocity v naught, and we have this as capital L, and let us suppose this is given as A, the displacement. Therefore we can say that v naught is the velocity at mean position, which will be given as A multiplied by the angular, and we can further simplify it. V naught will be equal to A square root of G upon capital L. And from the figure we can say that A will be equal to L theta naught. We are going to use, let us suppose this is equation number 2, equation number 3. So using equation 2 and 3, using equation 2 and 3, we get that V naught is equal to L times theta naught and square root of G divided by capital L. Now we are going to substitute these two. Let us call this equation 2, this equation 3, and this will be equation 4. Okay, this is 2, 3 and 4. So we write this as equation 3 and equation 4. So using this value of V naught in equation 2. So we can write from equation 2 we get WP is equal to mgl plus half m. Now it is V naught. V naught we are going to substitute. This is L theta naught square root of G upon L whole square multiplied by 2L upon capital L. We simply, now it is simple simplification, we get this is mgl plus half m, this will be L square theta naught square G upon capital L multiplied by 2L upon capital L. So we get 2 and 2 cancels out, L square also cancels out, and we are left with WP is equal to mgl plus, we have mgl theta naught square, mgl theta naught square, and taking mgl as common, so we get WP is equal to mgl 1 plus theta naught square. So this was the required. We were required that the work done by him this is the work done by the person. This is the work done by the person. And from the option available, you can say that option number B is the correct option. You can say option number B is correct. So this completes the question. Thank you.